Okay, we're going to do something similar now, except this time we are talking about equal payment series, but we are trying to figure out what the equal payment should be in two different scenarios. The first scenario, we want to know what is the equivalent payment required over 10 years if you wanted to have $50,000 available in 10 years' time, assuming an interest rate of 6%. So cash flow diagram, starting at 0 to 10 years. We want to know if I want to have $50,000 available in year 10, what do I have to contribute every year for those 10 years, including year 10, because remember end of year payments. What does that amount equate to? So we'll pull out our formula and our interest factors. So the formula is, what is A if you know your future amount? And the formula is something like this. I over 1 plus I to the n minus 1. It's essentially the inverse of the formula when we're solving for f. Or we could say A is equivalent to f multiplied by the factor A of f at that interest rate for n years. And again, like we did in the last problem, we'll solve this over both ways. So in the first case, we know we would like to have $50,000, and the interest rate is 0.06 over 10 years. And I think if we remember our numbers from previous question, 1.06 to the 10 is 1.790848. 0.06 divided by 0.7985 is going to be 0.075868, resulting in a total of 50,000 multiplied by that is $3,793. Let's double check that value and see if we get it when we look up our interest factor. So $50,000, what is A of F? That's 6% for 10 years. The interest factor in our table is going to be our sinking fund factor in column 3, 0.759. 0.759. Giving us the same value as we had below, approximately. So what this is saying is that we would have to save $3,795 each year for 10 years if we wanted the equivalent amount in 10 years to be 50,000. Next problem. What is the equal payment required to pay back a loan of 50,000 that you take out today if you'll be paying for it for 10 years? Assume a rate of 6%. Draw the cash flow diagram. Okay, so in this case, we're dealing with a loan of 50,000 right now. We're saying, well, we want to pay it back over 10 years. How much does this value have to be if we want it paid off by that 10th year? So we want to solve for A, and that when we know P, and that function is, if you recall from the inverse, fairly complicated. Sorry, looked up the wrong one. It is I multiplied by 1 plus I to the n all over 1 plus I to the n, subtract 1. Or what is A given P at the interest rate for n? So we took out 50,000. What do we need to pay that back? I'm going to cheat this time and look up my interest factor. In my table, and A given P at 10 years is 0.1359, 0.1359, and that calculation equates to $6,795. Cheating because I don't want to do the math on that one. But double check if you'd like. So that's how much we're going to have to pay per year, 10 times. And if I go back up to the last problem, this really should be written in terms of a yearly number as well.